Morning, everyone. Thanks for joining us. We are now live at BeyondX. I'm Sharum from Rankin and Hill, Singapore.
Hi, and I'm Daniel here from ONG&ONG Singapore. So just a bit of a housekeeping about the Zoom session. So all your mic and cameras are disabled. So if you want to make any comments or questions, we have chat box and also the Q&A. I'm sure you know where to find, which is on the bottom right or bottom left, right?
Okay. Basically, why we have BeyondX is that BeyondX is our annual event. BeyondX is the annual design festival, showcasing fresh technologies and speakers to inspire creativity and innovation, where we invite the most prestigious speakers in their field to share knowledge and developments with the world. Okay, for this year, we have invited 10 distinguished speakers from diverse backgrounds to share their knowledge as we explore the ways smart technologies and digitalization can inform the future of the EEC industries.
Yeah, for this today's event, we have a total of 8 sessions. So today is the second day, first session or second day, right? So we have speakers from Autodesk. So we have 2 speakers today. Robert Bob Bray, he's a senior director and general manager of Autodesk Tandem. Bob has served several products development roles, including leading development for BIM 360 design and InfraWorks during the last 20 years of Autodesk. Now he looks at the incubating new business initiatives and transforming the built asset lifecycle with digital twin technology and solution from Autodesk Tandem. Second speaker would be Tim Kelly. He's a senior product manager from Autodesk Tandem. Tim is responsible for shaping Autodesk Tandem and its workflow. He brings with him his wealth of industry experience, which includes a BIM manager role, along with product knowledge and experience at Assemble System and Autodesk.
Okay, before we start, just to take note, audience questions will be addressed at the end of the session. Okay, let me pass the mic to the speakers.
Hi, everyone. Just give me a second. Welcome, everyone. We started this project in February of 2020 and quickly learned 2 things. First, if you ask 10 people what a digital twin is, you'll likely get 10 different answers. We also learned the process of creating a digital twin today is challenging. Today, each digital twin requires a fairly costly bespoke process of data collection and validation that is typically conducted sometime after project turnover. We also realized that all of the data required to create the foundation of digital twin is data that is created or captured during design and construction. Autodesk Tandem was born out of that realization that if we could harness the data from design and construction, then we could create a highly repeatable process for realizing digital twins. Quick disclaimer for Autodesk. There's a poll question. I'll let you guys answer the poll questions. Quick disclaimer from Autodesk. I will be talking about some product features, so make purchasing decisions based on what you see in the product today and not based on what I present in terms of features. In terms of digital twin opportunities and challenges, let's start by defining a digital twin and look at the opportunities they present and the challenges getting in the way. The digital twin is a digital replica of a built asset. What's important is it's a dynamic digital reflection of its physical self. They possess the operational and behavioral awareness through that bidirectional connectivity necessary to simulate, predict, and inform decisions based on real-world conditions. I think more importantly, digital twins provide the means to really transform the built asset lifecycle. And we can affect that transformation by tracking what I like to call a digital thread of information that links organizations and data with an end-to-end digital process that spans capital planning, architecture, engineering, construction, and asset management. Transformation starts by understanding the owner's desired outcomes, their data requirements, and beginning to track that digital thread through the planning, design, and construction lifecycle to create a digital replica of the as-built. The digital thread can then be extended by connecting the digital replica to asset management activities, including space planning, maintenance, and IoT devices. This enables collection of operational and performance data and provides the opportunity for predictive insights. Operational and performance knowledge collected by the twin can then inform the capital planning portion of the lifecycle, giving owners additional insights such as, is my facility achieving my sustainability goals? And if not, what can I do to course correct? Which systems, equipment, and materials perform better than others across my portfolio of assets? And what future planning and design decisions will maximize the return on investment from my portfolio? Verdantix proposed a maturity model for digital twins that was comprised of 5 levels. The base level they call a descriptive twin, which is comprised of a live editable version of the design and construction data. You can think of that as an as-built representation of the building context created from BIM along with the design and construction data. Does not need to include all the nuts and bolts in the curtain wall or an LOD 500 models. Needs to contain the asset spaces and systems the owner cares about to operate that facility effectively. They add to that the notion of an informative twin, which adds operational and sensor data, potentially work order data, other types of operational data to really make that twin a single pane of glass for operating the facility. Predictive twins begin to leverage all that operational data for insights, and then they add on the idea of a comprehensive twin for adding simulation, what-if type scenarios, and autonomous twins that have the ability to act on behalf of users. Turn off the lights when everybody goes home, call the elevator automatically when somebody badges into the building, maybe self-tune a processing facility. Each level in this matrix requires a greater degree of BIM maturity and digital transformation, not just for the AEC firm, but for the owner as well. But each one of these offers much greater value to your customer's business. So why is digital transformation so important? A recent FMI report on engineering and construction suggests that as much as 95.5% of all data in design and construction goes completely unused. And while that statistic is pretty scary, owners are beginning to recognize the need for a more collaborative approach on future projects. And 58% have indicated they are moving in that direction. One of the inherent problems we've heard is they can often take 9 to 12 months to go from project turnover to an operationally ready facility. Why is that? It's really because at handover, owner and operators receive typically an analog, unclassified, and disconnected set of data in a set of files. That leads them into an insurmountable challenge in terms of creating an integrated solution for monitoring, managing, and tuning their asset. And the result is that owners are unable to really realize the benefits of their smart buildings and instead end up with siloed data and systems, inaccurate information, a lack of transparency, and poor insight into their asset performance. What they need to receive at handover is that descriptive digital twin that indexes all of that handover documentation. A recent study by Accenture showed the potential return on capital employed an owner-operator could achieve through digital transformation. Not surprisingly, the biggest gains can be achieved by really incentivizing project stakeholders to work in an integrated fashion and deliver digital, which can help realize more value through efficient use of resources and adoption of more innovative processes and methods. However, to achieve the full benefit, owner-operators also need to invest in data sharing and data-centric talent. Autodesk Tandem was created to support digital transformation and help owners move up the digital twin maturity scale, empowering owners to realize their digital twin vision. With Autodesk Tandem, you can create and execute a repeatable process for curating a descriptive digital twin through digital handover. That digital handover process is the key to delivering that descriptive digital twin to the owner at handover. From there, you can connect that Autodesk Tandem descriptive twin to operational workflows and systems to break down data silos and provide a single pane of glass for smarter operations. And eventually, analyzing the operational data collected by Tandem will empower greater insight to inform future decisions. I'll give a quick caveat here. Our focus today is very much on digital handover. As we move Tandem forward over the next year, 2 years, we'll be adding smarter operations and greater insight capabilities to the product. Now let's take a closer look at Autodesk Tandem and how it can help create a digital twin by tracking that digital thread of information by starting digital, staying digital, and delivering digital. Autodesk Tandem's digital handover workflow enables you to harness the BIM process to make digital twins a highly repeatable natural output of the project lifecycle. BIM experts have talked for years about beginning with the end in mind, and Autodesk Tandem enables customers to do just that by specifying the data requirements necessary to achieve the owner's desired operational outcomes. To get the best results, that should be done in direct collaboration between the owner-operator and the project team. By leveraging Autodesk Tandem's facility templates, you can achieve repeatability and data consistency across a portfolio of facilities using the processes outlined in ISO 19650 Division 3. Depending on the owner's needs, data requirements can be completely customized or specified in terms of open standards such as COBie, Building Smart, or any of the emerging building ontology standards. Creating a facility template in Tandem is a 3-step process. It starts by defining your asset breakdown structure, which can either be based on a standard classification such as master format, uniformat, omniclass, or you can build your own custom asset breakdown structure based on the owner's needs, possibly specified by an existing CMMS system like Maximo. Second, you leverage our library of predefined parameter sets based on standards such as COBie and Building Smart to create parameter sets that define what data needs to be managed within your digital twin. You can also create your own custom parameter sets. Finally, you define a facility template by specifying your asset breakdown structure and which parameter sets apply to which asset types. Note that the parameter sets act as building blocks of data such that the data for each asset type can be defined from multiple parameter sets. Tim will demo this in just a minute. Once the data requirements are specified, Autodesk Tandem enables customers to capture the required data from the design and engineering intent and from the as-built installation and commissioning data. This data creates a digital replica of the facility within Autodesk Tandem and tracks every change made, providing that digital thread of information for every asset and space in the facility. Autodesk Tandem is designed to integrate with and extend our existing design and construction offerings, such as Autodesk Revit, Autodesk Docs, BIM Collaborate, and Autodesk Build. The capture process starts by bringing model data into Tandem to form the basis of the digital twin from Autodesk Docs or another common data environment. Once in Tandem, the data can easily be filtered to work with a specific subset of assets so that you can apply an asset type to a filtered set of data and then capture the parameters specified for the asset type within Tandem. Give it to another team and use tools like Microsoft Excel or in the future in integration with Autodesk Build. It's also important to note that all the design model metadata is available within Tandem and can be directly mapped into your asset properties, eliminating any duplicate data entry. So if you already have a lot of this parameter data captured in Revit, you can pull that and basically map it directly into Tandem's asset properties for use downstream by the owner. Final step of digital handover will be to provide a rule-based system to verify the completeness and accuracy of the asset, space, and system data. Today, this is typically a manual and error-prone process, and some customers utilize third-party model checkers. What's important is following that ISO 19650 Division 3 process, understanding what data is required, who the responsible party is for delivering it, and making sure that data is delivered by that party on time, meeting the requirements of the digital twin. Inside of Tandem, what's happening is that digital handover workflow is creating that descriptive twin of the facility with a well-defined information model. The facility template describes the schema of our asset information model. Within that model, each asset is classified and tagged with additional data according to the owner's requirements, which includes links to the necessary documentation for that asset. Assets are part of systems that serve spaces in the facility, and Autodesk Tandem is designed to infer and leverage these relationships. As we progress into owner-operator workflows, a subset of these tagged assets will become connected assets that also receive telemetry data from an IoT system, can be connected to work order history, and track all that maintenance data along with the asset. Tim will demo some of this in a few minutes as well. Digital handover achieves better outcomes by providing that data-centric platform for collaboration between the owner, the architect, and the contractors regarding asset information requirements. And more importantly, at handover, it provides easy access to all that detailed facility information through the digital twin that can rapidly accelerate operational readiness of the facility. Now let's take a quick look at the future at how Autodesk Tandem will enable owners to transform the built asset lifecycle. Beyond digital handover, Autodesk Tandem really provides that context to connect operational data and systems. With these connections, you can answer and visualize complex questions like, if this component fails, what spaces are affected? Where are these assets and how do I access them? And how does the built asset perform against my desired outcomes? In recent conversations with owners, we've heard about owners spending most of an 8-hour maintenance window just trying to find the valve that needs to be shut off in order to start the maintenance procedure, leading to a lost time and effort. Having a solution like Tandem, where the model can provide guidance to the asset, what tools you need, what equipment you need, all the documentation accelerates this process greatly. We'll create the connections to operational data by linking the asset spaces and systems in Tandem to operational systems and data. Autodesk Tandem can help accelerate operational readiness by using the asset and space data to initialize CMMS systems, building management systems, IoT, and other systems. And by establishing those bidirectional connections to real-time and operational data, we plan to deliver that single pane of glass for monitoring and operating your facility. I think it's important to note here, Autodesk is not out to build an IoT platform. Our goal is to integrate with leading IoT platform providers such as Microsoft Azure, Amazon's Web Services, IBM Solutions, and others. We will, however, bring all the learnings from solutions like our research projects like Project Dasher into Tandem, but supported by that highly repeatable and scalable process for our customers. By analyzing all of that data that's coming into Tandem through those operational systems, we can start to understand how the desired outcomes of the owner match the actual maintenance events and facility performance. Autodesk Tandem will be able to report which assets and systems are performing as expected, better than expected, or worse than expected. This information can help predict events to improve availability and inform decisions to maximize an owner's return on investment. Autodesk Tandem's facility templates ensure that data rolls up consistently, providing insights not just for a single facility, but across an entire portfolio of facilities. Hopefully it's clear that Autodesk Tandem's roadmap has been intentionally structured to help our customers move up this digital twin maturity model, starting with our near-term focus for delivering workflows to help curate a digital twin, and then beginning to move up the maturity scale through integrations with IoT and operational systems. We believe this roadmap will result in a solution that enables our customers to create a highly repeatable process for curating digital twins and begin to take advantage of their operational benefits. The base offering Autodesk Tandem is a SaaS offering that focuses on the needs of our AEC customers who want to curate that digital twin through a digital handover process. The offering will give our customers the workflows necessary to specify the data requirements and capture and verify the necessary information to enable digital handover. In the future, another offering, Autodesk Tandem Pro, will come to market that will really target the needs of the owner-operator by extending those core capabilities of Tandem with the ability to connect to the assets in the digital twin to IoT and operational systems. All of this is built on something we call the Tandem platform, which extends Autodesk Forge with our cloud-based asset information model. With that, I'll hand it over to Tim to give a quick demo, time permitting.
Thanks, Bob. If you'll let me share my screen, I'll jump in quickly. All right, I'm going to walk through in our product a couple of the workflows Bob described, and I'm going to move quickly so we can get right into our panel discussion. But what you're seeing here is a facility within Autodesk Tandem. If I look at my portfolio list, I can navigate into a facility quickly. And the first thing that we would ultimately do when setting up curating information for a digital twin is we do start with BIM. So we're going to incorporate our models. In our case, we can directly upload Revit files or reach into a Docs account, either in BIM 360 or Autodesk Docs, and incorporate files from that location. In the case that we incorporate our models and want to run an update, as Bob talked about, we do capture that digital thread from end to end, and we ultimately want to keep history of all of that information. All changes that occur in our platform are tracked. And so when we do update versions of a model, we do capture that history. I'll show that history thread in just a moment. As we incorporate our models, we can start to leverage the data that we've incorporated to drill in on specific data sets. In this case, I'll use level system as defined in Revit, mechanical equipment, and I can quickly isolate information or create subsets of assets, and ultimately look at that information both visually in our viewer as well as tabularly in our inventory. As I set up these views or ultimately these filtered data sets, I can structure this in a way that allows me to very quickly identify what I'm looking at in my inventory, and I can save this state to return to at a later point in time. So I have a few views here that allow me to switch very quickly from system to system, and ultimately different asset packages that allow me to review specific components, whether it's by location or by a category or by system. So as I set those views up, it allows me to very quickly populate information for those particular views. As Bob talked about that process of specification or defining our requirements for the digital twin, ultimately that consists today of three parts: defining your classification system, or ultimately the structure of data as it's specified by your project team or by your client. And in this case, ultimately it can follow industry standards such as unit class, or it can follow a definition that your owner has provided, and you can customize this as appropriate. In this case, I have very simple grouping and asset types as part of those groups. So we have ultimately unlimited flexibility in how we can define our organization structure for assets. The second step is defining your parameter sets, and ultimately within a given parameter set, we can define the data that we want captured for a given asset type or an asset group. In this case, we can specify whether it's linked information, text data, numerical data, and ultimately the context and how we apply it to the facility, whether it's at the individual element level or across an entire type. So as we set up this information, then we ultimately, as Bob talked about the process of a repetitive application, we ultimately want to allow for structured application of this data to a set of templates. So in that case, what we have provided the ability to do is define a classification system or use one of those that you've uploaded, and then ultimately align the parameter sets with that classification system. So in this case, I have a top level or level one hierarchical structure with a parameter set applied. I have an item below that ultimately with an additional parameter set applied. And in the case that I apply, let's go down one step further, an additional parameter set here. Ultimately, what you're going to see in our product when we apply this to a facility and define a set of assets as fire suppression sprinkler systems, you're going to see the data requirements to be captured are for this parameter set and this above, as well as this above. So when I go back into my facility, what you'll see for a given asset that I select is that I've defined this as part of my hydronic pump asset type, or classified it there. And ultimately, I've incorporated all of the information as defined in that facility template. As we apply a facility template, as I mentioned, you're defining the specification system or classification system, as well as the parameter sets. And you do have an opportunity to capture information that may have been incorporated in your Revit model or your Revit data as you've incorporated into the Tandem product. So we do have a mapping process as you define that template. So if I look back at these properties and ultimately over time information changes, or as data is captured, we do track a full comprehensive history of this information. So if we want to look at data changes over time, I can see for a given parameter that it's changed over the course of the facility's history. And we do track that across the entire facility and allow for review of that information from various aspects of incorporating or changing data in our ecosystem. As I mentioned, in terms of defining the parameter set, that can be text data, calendar, time data, numerical information with the unit of measure, as well as documentation that allows me to link out to external documents and incorporate those into your asset definition. As if I really quickly just pull up the inventory as well again. Ultimately, as we capture data, we can do that directly in our parameter a properties panel here, as well as a copy and paste to fill down or Excel type interactions with our inventory, and ultimately incorporate information from outside of our product through export of this data table to Excel, capture data there, and bring that back into our system. With that, I believe I'm going to go ahead and stop the demo and we'll jump into the panel discussion.
Thanks, Bob, and thanks, Tim, for the presentation. Okay, so maybe if I can summarize for the benefit of the audience and the rest of us here. So basically, with the roadmap of this near terms and midterms and so on, right? So we have descriptive, informative, and predictive kind of data that can be presented in the platform, right? So we also have the comprehensive and autonomous at the end of the day, right? I think that's the kind of key things that I think you guys talking about this morning, and also the importance of data-driven kind of a platform. For this FM systems, I guess also IoT, BMS, and things like that, and the fact that the platforms actually connect pretty well with the current offering of BIM 360 and Autodesk Docs, with the parameters, COBIs, and other classification system also can be as we can see on the Teams demo just now, it's like all things are in the so-called the dashboard platform and all that. Yeah, I think this perhaps is can summarize the idea what we're gonna discuss today, right? So maybe Sharon, maybe if you want to start with the question first, then after that I will follow up with my series of questions later. Oh yeah, just before we do that, I think we started the poll questions early today. So maybe for the audience, if you haven't launched the poll, please just select and respond to that, and perhaps we also can discuss about the how about the respondent and results after this. Sharon.
Okay. In fact, I have a few questions, 3 questions in fact. First question, how does this push for a data-centric approach to building to a sustainable building operation? That is the first question. The second question is, since a digital twin enables collaboration between IoT and sensors throughout the building, will it be then integral to the FM to diagnose and fix problem even before become apparent to the building occupants? That's the second question. The third question is, I think, applicable to this local industry in which it seems there will be quite in the sense, in particular in private sector, there will be a resistance from the developer to adopt this thing. So how do you think the best or critical push factor for this owner or developer to adopt this thing? These are my three questions.
I'll start with the first one on sustainability and really driving better sustainable practices. I think we can all design buildings with sustainability in mind today, but do we actually understand how those buildings perform in the real world? And the best way to achieve better sustainability in the future is to complete the full life cycle. First, by designing the sustainable concepts in mind, then understanding how those concepts actually perform in the real world, and then using that data you're collecting from those buildings to inform future design to make even better buildings in the future and more sustainable buildings in the future. So that's the way I would address number one. That's the long-term goal for digital twins in general.
And Bob, just given it's relevant, the Olympics are ongoing at the moment. It's probably appropriate to compare building performance to the way athletes today improve their performance. So they do, they're looking at every data point and they're collecting all of the data about the way they perform. They make a small change and then they analyze the results. And then they make a small change and they analyze the results. And when we think about sustainable building operations, we ultimately are collecting that data about what are the results. And we can ultimately use that information to make adjustments and then take all of that forward as those small changes add up. And over time, over the life cycle of that building, as Bob mentioned, you are looking at a more sustainable process for operating a facility.
Great and timely example, Tim. And the second question, I think, was really about, two things. One is enabling the FM process and also having that building respond and detect a problem before it even occurs. And there's a couple of really good examples here. One, if you are looking at data and performance for a building, you can start to see drop off of a piece of equipment before anyone in the building ever recognizes that drop off is occurring. I think more importantly, if you have multiple data points correlated together, then you can start to quickly not only understand there is a problem, but solve that problem before it ever affects the building occupants. For example, maybe there you noticed a pump is starting to drop off its performance in the building. But you can correlate that to it started dropping off exactly 2 weeks ago when a maintenance event was enacted on an upstream piece of equipment. So now I can say, well, it's not the pump that may be at fault. Maybe I need to go back and look at what happened in that maintenance window that happened 2 weeks ago in an upstream component. So drawing these correlations allow you to fix the problem before it ever becomes a real world problem for the building occupants.
And that's I'll add to that, Bob, and that example is fantastic, thinking about the correlation you're making. In our case, the way we think about our data model is you have assets that serve spaces, that exist in spaces, and those things are connected by systems. And ultimately, each component or each space, there are multiple systems there at play. And so in Bob's example, measuring the flow of a pump, potentially you also have a consumption meter, electric consumption of that motor that's part of that pump. Well, you can have really quickly a correlation of a spike in electrical or energy consumption might point to a failure in that device of that upstream component or of the pump itself. So you have a number of different ways to look at this information once you start to tie it all together. And as Bob talked about or described that single pane of glass approach, being able to incorporate data from multiple systems really enables that process to occur.
And I might need the third question repeated because I don't remember.
Okay, the third question is basically about the resistance in adopting the twin technology, especially in the private sectors in the local context here. So what would be the critical push for them to adopt this technology?
I think the critical push for owners is, and I'm going to address this differently for owners versus project teams, right? For owners, the critical push is really achieving a more sustainable future for their buildings, better performance for their buildings, better uptime for all of their equipment, and really making sure the occupant experience is world-class for those building occupants. And that could be just in terms of some autonomous operations in the building itself. That could be in the way you perform maintenance, as we described a moment ago. It could be in energy savings and reduction in carbon emissions. It could be many different factors that result in those cost savings. For AEC teams, I think it's different. It's giving more value to their customers and really creating a tighter relationship with the owner in terms of providing that data-driven deliverable. I've talked to a lot of AEC firms today that are starting to get RFPs with digital twin type requirements in those RFPs. And this gives them a way to respond to those RFPs in a consistent way. But also, what they're really doing is delivering more value to those owners. And at the end of the day, that's creating a better relationship with that owner and probably repeat business. So I think that repeatability of business between the owner and the AEC firm, creating that trust and really creating a more collaborative environment between the AEC firm and the owner is a huge benefit to the AEC firm overall. Do you have anything to add to that?
Yeah, I think you really nailed it, Bob. The only thing I would add is something that we do talk about frequently when we think about that carbon footprint or ultimately the cost of operation. There's a stat we use that is, roughly 20% of the cost of a building over its life is in construction, and the remaining 80% is in operation. And so when you think about that staggering value, any impact to that, it can be substantial, both in sustainability goals you have and that carbon footprint potentially in energy consumption, as well as that cost of operations. So if you think about it in those kind of numbers, it makes it really tangible when you think about those incremental changes that we discussed.
Daniel?
Okay, yes. Okay, let me switch to the audience pool here. Let me just share the result now. Okay, so as you can see, oh wow, okay, so we have, okay, not interested, but not yet using. Okay, that's good. Okay, so we also have, I guess, quite a number of BIM users here that, would like to use BIM for FM, but perhaps haven't got the opportunity, or maybe they're gonna use it in the future. So I think speaking of BIM, for example, I think one of the audience also asking, right? I mean, how, what things need to be prepared? Say, for example, if they're using Revit, right? Any modeling guidelines for Revit software, for example, so it can better integrate with Tandem down the line.
I'll jump in and say, honestly, we've built Tandem and with the mindset that you potentially don't have control over the Revit ecosystem or the models that you're consuming. And so we do have flexibility in normalizing that data and providing structure downstream within our product. However, I would say the cleaner the model, the better. So if you're applying naming schemas or standard structures for your different assets, your different systems, fantastic. If you're appropriately making connections for your systems, fantastic. Ultimately, we are following guidelines provided in ISO 19650 Division 3, which is the operational phase of asset information. And within that, ultimately, what it defines as a part of that project team is that you structure your classification system as a team, and you make those decisions as a team, and then ultimately you define what data you care about and how you want that applied within that classification system. So as we showed our specification process, it's really following that, and if appropriate, start applying that up front in the way you model and the way you begin your design, and let that flow on downstream into this curation of digital twin information.
But I'll add one thing to that. If if the Revit models needed to be clean, we probably wouldn't have any customers for Tandem because I've never been a clean Revit model.
That's right. That's right.
I think at least 1,000 warnings from each project, I guess, from the one that I know.
That's right. That's right.
I guess. All right. So I guess in terms of interoperability, like things with standard format like IFC should not be any issue, right? I believe.
We are in the process right now. We are Revit centric, but we do ingest all data into Tandem through the Forge platform. Mm-hmm. And as we go forward, IFC, Navisworks, and many of the other Forge supported formats are very high on our roadmap for implementing the Tandem. So those formats are definitely coming very soon.
Okay, cool. Yeah, I mean, like with Forge technology, I think it's been great for us. I mean, at ONG&ONG, for example, I mean, we host everything in there. All projects of ONG&ONG is all there. Rankin and Hill as well. I think Sharon knows about it. We have, I think, over 2,200 plus projects right now. I mean, all in BIM 360. We haven't yet moved to docs. So what is the tips and I guess from you guys, like for example, we as a consultant, right? I mean, yes, we set the so-called the common data environment now in BIM 360. Mm-hmm. I mean, is it the right move, or how we're going to move forward if we want to integrate the platform in the future for Tandem?
Yeah, we see Autodesk Docs, BIM 360 Docs, BIM Collaborate, right? That is our foundational, really ISO 19650 Division 2 compliant environment for managing all of your file-based and document-based data. And we see Tandem as a layer on top of that, supplying your Division 3 asset information model. So these two things are designed to work. I'll use the term in tandem, and really build upon one another. So if you're using those tools today, that's really your best on-ramp to Tandem in the future and delivering digital twins. And then the other thing I would say is that really work with your owners to understand their asset information requirements, what their desired outcomes are, what their data requirements are. And that's really going to help you focus on delivering that digital deliverable in the future.
I mean, is there any like a plan or roadmap to connect, say, for example, as a consultant, we use this BIM 360 or Autodesk Docs now, but our client side is actually using Tandem. So how we connect these two CDE platforms together, right? Because they obviously not so-called have too much interest on the design authoring kind of a data set, but they're more towards on the FM, more towards on the handover model,
I'll jump in, and Bob, you can add, but ultimately Tandem does not have an internal document store. We are currently in the process of working through this, but as I showed in the model consumption, we are reaching into your Docs account. So that Autodesk identity, your Autodesk ID is shared across the platform. Again, this is Forge components, as Bob talked about, the model consumption, but that means that when you log into Tandem, ultimately you will have access to the Docs account that your account has access to. And in the case that we go through this handover process, our expectation is that we encapsulate all of the documents that you have linked that are stored in your current Docs account into that Tandem ecosystem, wherever that needs to land for your client. So that handover process will be truly a copy event where we're cloning that data to another environment wherever they define or specify.
Okay.
I will note that is future functionality, the way I just described it. So just a comment that's not currently in our product today, but that's a plan that we have and the way that will interact.
Okay, got it. I think we have one audience here asking, can similar concept be deployed to township development? So perhaps it's in Singapore context, I guess, would be like, because we are pushing for the smart nation with IoT and all that thing, right? Of 5G, for example, as well. So what do you think?
So deployed in terms of your local cloud infrastructure, right? That's the question.
I think, Bob, I think it's related to township development as in like campus type or larger scale
Got it.
Yeah.
Yes.
Exactly. Because we're talking about building just now, but I think perhaps they're thinking more on the larger scales of development rather than standalone. You know what I mean?
Thank you. Thank you, Tim, for the clarity. So the way we think about digital twins is they're a federated environment, right? You start with a piece of equipment that might be a pump or a piece of fabrication machinery in a plant that has a digital twin. You aggregate that into the digital twin of the factory or the building. That building aggregates into the digital twin of the campus or the city. And so that's the way we see this building up over time. And we are definitely working with our partners like the SRI and others to think about how we can stitch together mini building digital twins into the infrastructure of a city scale campus or a campus type environment. So we are thinking about it as a federated, aggregated environment.
Yeah, and at the township level, we do definitely think that GIS data is important at that point. And so, as Bob mentioned, working with our partners like ESRI and how we incorporate that, and then navigate between GIS information and ultimately the BIM data structure we have in our product with a hierarchical structure there.
But at a facility level, you care about a lot of things inside that facility and that building. At a city scale, you care about some very high level characteristics of that particular building, how many occupants are in it, its current carbon emissions and maybe energy consumption and things like that. So you can roll up those high level indicators to give you that city scale representation.
Okay, I see. So I think in the from the Revit users kind of analogy, perhaps like, okay, Revit is building, and then we use InfraWorks actually to do the master planning, that kind of stuff. Is that sounds right?
Yep,
exactly.
Yeah,
okay.
and just for reference, we are having conversations with those partners and how we would provide that federated environment. Again, early stages at this point, but we're certainly thinking about it, and we're certainly discussing that. But great analogy that multiple product approach. This is an ecosystem. Ultimately, we don't see a digital twin as a point product that allows you to do all things in one product. This is a ecosystem type of approach.
Okay. Sharon, you have anything more?
No, that's all for me. Is there any more questions we are looking at?
Yeah, I think nothing else for now. What's the time? Okay, all right. So we've just reached 45 minutes then. Okay, good. I think perhaps we can wrap up now. I mean, if there's no more questions. Sharon?
Okay, then let us wrap up this event. Okay, thanks everyone for attending this session. We hope everyone found this session enlightening. Okay, I would like to thank you, Bob and Tim, also for hosting this event, and our audience too. Okay, please go ahead to check the event schedule for other interesting and informative BeyondX sessions. So on behalf of my co-moderator, see you in the next cycle of the BeyondX next year. Okay, thank you very much, everyone.
Thank you.
Thanks, Bob. Thanks, Tim.
Thanks all. Take care.
Bye-bye.